Alright, let's take a look at section 6.4, similar and congruent figures. Now similar figures are two figures that are the same shape, but they're different sizes. So they're similar to one another. Think of like Austin Powers, and there's like Mini-Me and Dr. Evil. They're not, they're different people, but one's smaller. It's the same thing, but it's a different shape. So same shape, same overall shape, but different sizes. So it's like you would like zoom in on one, or one's like miniature of the other version. So that's what similar figures are. And to show that, we use this symbol, which is, it almost kind of looks like an S. So if I were to say like triangle ABC is similar to triangle DEF, I could write something like that. They could have the same shape and different size. And if I look down at these pictures here, I have four different triangles. The two that are the same shape, just by looking at them, would be most likely triangles ABC and DEF. And I can tell you for positive that these two are the similar ones. So this is obviously not a match, so that's nothing. And this one looks like it could be, but this angle is a little too steep, so that's nothing. So typically when you do these problems though, you're not going to have to just guess or assume. You're going to have to, they'll tell you the information, and then you will go ahead and figure out the things from there. But assuming that these two are similar, we can see here that they are the same shape, but DEF is smaller than ABC, so the same shape but different sizes. Now with similar figures, you have corresponding parts, and corresponding parts just means parts that are in the same position. So for example, AB, this line here is in the same location as DE, so those are corresponding parts. AC is corresponding to DF. BC corresponds to EF. So corresponding parts are the parts in same relative position. So let's take a look at some properties that come out of this so we can analyze further problems. Properties of similar figures. Now, they're telling us, this is what I mean, they'll tell you triangle ABC is similar to DEF. So they're saying that these two are the same shape and they look like that, but they're saying they're just different sizes, and we can tell that as well. So, first part, corresponding angles of similar figures are congruent. So that's referring to the angles, not the sides, but the angles inside. This area here, this angle, this angle, this angle, okay? And we don't know, it looks like a right angle, but since they don't tell us, we can't really assume that. We don't want to do that, but we can see that it is an angle. So they're talking about these angles, and they're saying corresponding parts. When we have similar figures, corresponding angles are congruent. So angles in the same location are going to be congruent. That means they're going to be equal. We talked about congruent. Congruent means exactly the same. So we want to keep that in mind. So for instance, in this case, we have angle A would be congruent, and that's the symbol for congruent, to angle D, because they're exactly the same. Okay? We could say angle B is congruent to angle E, because they're exactly the same, and we know that because they're in the same spot of similar figures. And then lastly, we have angle C is congruent to angle F. Okay, and that only works for angles. We can't do that with sides, but just angles. Now if we look at part 2, the ratios of the lengths of corresponding sides of similar figures are equal. So the ratios of the lengths. So now we're talking about the outsides. So let's take two sides, for example. How about CB? CB is 3, and they don't give us units, so 3 whatever. Now the corresponding part to CB is FE. FE, and FE is 6. So we see that our ratio here is 3, 6, or 1/2. The ratio between this triangle and this triangle is 1 to 2. And what this part 2 says is that the ratio of the lengths of the sides of corresponding sides of similar figures is equal. So we could pick any other side and we should still get 1/2. So let's do BA. BA is 5, and ED is the corresponding part. It's in the same location, and that's 10. 5 over 10, just 1/2. So we could choose any of the side corresponding pairs, and we're still going to get the same ratio. And what that means is for every 1 unit that this triangle is, this one's double that. It's 1 to 2. So that's the ratio, 1 to 2. Okay? Let's take a look at the second page. Oh, there we go. Here they're telling us triangle LMN is similar to triangle PQR. Now in this one, it's a little bit, obviously we can see the shapes look the same, but and one's smaller than the other, but they're not in the same orientation, meaning they're not the same like location. This one has the long point on the right, this one has the long point on the left. It's like a flipped version. So a little way that you can figure it out without having to contort it in your head or twist it around is work off of what they're giving you. LMN is similar to PQR, and they want us to list all the corresponding angles and corresponding sides. So angles first. N is this pointy one, so that corresponds to the pointy one here, which is angle R. So angle N is, and we know that angles are congruent, so we can write the congruent symbol. Angle N is congruent to angle R. And I want you to look up here. Angle N is the last letter, and angle R is the last letter. And that's really how it's going to work. So I could say L and P, and if I look at my picture, L is right here, P is right here. These are the corresponding angles, and they also work. So L is congruent to angle P. And then the middle one is M and Q, and that's M right here and Q. So we don't even really need the picture. It helps, but we don't need to have it. As long as we have this up here, we can go ahead and figure out our corresponding angles, and it also works for corresponding sides. Let's say ML. So if we do sides, ML, and now that's the first two letters, or LM. ML is going to correspond to QP. QP is right here. So ML and QP. Then we could say MN, which is this line right here, and it's the last two letters, so QR are the last two letters, and that's what that's going to correspond to. So MN, QR. And then lastly we have LN, and those are the first and last letters, and that's going to correspond to PR. LN is this long one, PR is the long one, so we can see that we did it correctly and everything matches up. So that's how you list all the corresponding angles and sides. Alright, now let's apply this. Given quadrilateral ABCD similar to JKLM, find the ratio of the lengths of the corresponding sides of ABCD to JKLM. Alright, so we saw in our other property, we just have to pick one pair of corresponding sides. Whatever that ratio is, it's going to be true for the whole thing. So I'm going to do, how about the first two, AB. Now that's going to correspond to JK. Not a joke, just kidding. AB and JK. So AB is 8, JK is 12. So it's 8 to 12, which reduces to 2 to 3 when I divide by 4. So that's my ratio, 2 to 3. For every 2 that is, the other one's 3. Alright, let's turn the page. We're going to look at the last one. We're going to skip that one that I just went over and come to this last page. Congruent figures. Now similar figures are the same shape, different sizes. Congruent figures are, two figures are congruent if they are the same shape, same size. Okay? So everything, they're like cookie cutters of each other. They're exactly the same. And this is just another way of saying that. Two figures are congruent. If two figures are congruent, then they have the same shape, same size. Okay? So let's try it with one or two problems. These two figures are congruent. The symbol we would use would be this. And here they're telling us, in example 3, moving down just a little, ABCD, and they have the symbol here, the equal with the squiggle, is congruent to WXYZ. So we want to find WZ down here. We don't know it, but we can find what's corresponding. So WZ are the first and last, A and D are the first and last. AD is 12, and since they're congruent, WZ must also be 12. Congruent's exactly the same, and they look the same. Last is letter B, the measure of angle W. That's what M stands for, the measure. Measure of angle W. Well, W's first, A is first. A is 105, so this is 105 degrees. Good job!